All right, everybody. Hello, hello. So we're going to be going over the review of the moon review. I do just want to emphasize that there are some similar questions that you'll see on the video. For example, if you want to look for the walkthrough for numbers 1, 2, and 3, you're going to check out my tides and moon video. Check out my tides and moon questions. All right, for numbers 1, 2, and 3. I give a breakdown, so you can head over there, check out my Tides and Moons questions videos. So you can see the breakdown of the first 3 questions. Number 4, once again, this is a similar question that we went over. I want you for number 4, you can go ahead and check out my moon phases. My moon phases video, my moon phases question video. All right, you can check it out for number 4. They give you a breakdown of this question and many other questions as well. So once again, numbers 1, 2, 3, moons and tides questions. Number 4, you can check out my moon phases question on my channel. All right, so we're going to check out number 5. So it says, when a solar eclipse is viewed from Earth, the moon must be located at orbital position what? So once again, we're looking for when a solar eclipse is viewed from Earth, where must the moon be? All right, so first and foremost, if we go back to our notes, it tells us right here that a solar eclipse occurs. Let me just move that in. All right. A solar eclipse occurs when a situation when the worm passes into the moon's shadow and the moon blocks the earth from the sun. So basically, the moon has to be directly between the sun and the earth. Once again, for a solar eclipse, the moon has to be between the sun and the earth. For a solar eclipse, the moon has to be between the sun and the earth. All right, so then when we go over to our video, sorry. So I'm gonna scroll over up because we're using this diagram here, and the sun is right here, right? Because the sun's rays is located on the right. The earth is here. So for solar eclipse, where must the moon be? The moon has to be between the sun and the earth. It has to be between the sun and the earth. And so the only position that is between the sun and the earth is letter A, right? For a solar eclipse, the moon has to be in between the earth and the sun. And so when I take a look, that gives me choice 1 for A. All right, number 6. Number 6 says if the distance between the moon and earth were doubled its present distance, the moon's cycle of phases would occur blank. So first off, we have to know what causes the moon cycle of phases. Why do we even see the moon cycle of phases? Why? It's all because of the moon's revolution. That's why we have lunar phases, all right, or moon cycle of phases, because the moon's revolution. So therefore, that's the first thing, right? So because of the fact that the moon continues to go around the earth, that's the reason why we have moon phases, okay? Now, if they said that the moon was farther, right? So if the moon was farther from the earth, all right, so I'm just going to draw a quick picture. Bear with me, please. All right. So let's say this is the earth, right? This is the earth. And then now we're saying that the moon is farther, right? So this is the moon. We'll label it letter M. If the moon was farther from the earth, it would take a longer time for the moon to go around the earth, right? If the moon is farther from the earth, it's going to take a long time to go around the earth. So when I look at my choices, one of the things that I see automatically is that it's not going to be in reverse order, because the only thing that changes is just the distance from the earth, right? So it's still revolving counterclockwise. However, it's going to take longer to go around the earth, and so that's why it's choice 3. The farther you are from whatever that you're orbiting, the longer it's going to take to orbit. All right, so that's something to keep in mind. So the answer is choice 3. All right, so number 7 says a high tide occurred at 6 a.m. at a beach in Long Island. So a high tide occurred at 6 a.m. The next high tide at the same beach would occur at approximately what? So automatically, they tell me the first high tide occurs 6 a.m. That's important, all right? And then they want to know when the next high tide is going to occur. So do we remember how long it takes to go from a high tide to the next high tide? Do we remember, right? Go from a high tide to the next high tide. It takes, according to our notes, 12 hours and 25 minutes. 12 hours and 25 minutes, okay? So that means if the first high tide is at 6 a.m., 12 hours and 25 minutes later is going to be 6:25 p.m. We're still on the same day. So choices 3 and 4, it can't be. So now what's my best option? Remember, to go from a high tide to the next high tide is going to be 12 hours and 25 minutes later. If we started at 6 a.m., 12 hours later is going to be 6 p.m. 25 minutes later is going to be 6:25 p.m. And the closest answer to that is going to be choice 2. All right, number 8 says the diagram below shows the moon at one position in its orbit around Earth. Letter X indicates the location of an observer in New York State. And the question says, which phase of the moon will the observer see when the moon is at the position shown in its orbit? So we're trying to see basically what view is the person going to get when the moon is at this location right here. So remember our cone technique, right? And so we're going to draw our cone. Let me just enlarge this, right? Sorry about that. So remember, starting just from the center, I'm going to draw a straight line to the edges. So I'm going to draw a straight line to the edges of the circle and where the orbit is. Once I do that, I'm going to draw a straight line. A straight line, right? You almost want to complete the orbit. So that means we're only looking at this portion of the moon. Now, because of the fact that the moon is located on the bottom and we look up at the moon, we're gonna have to turn our paper to make it upright. So let's turn our paper. Let's turn it again. Let's turn it one more. Let's turn it one more time. Where we at? Where we at? Oh, actually, we don't have to. So now, as you can see, we are able to see the moon is upright. So let's draw what we would see. I see a little bit. Let me change the color. Sorry, guys. I see a little bit of white on the left. All right, a little bit of white on the left. And I see a lot of dark on the right. So a lot of dark on the right and little white on the left. On the left. Remember, all we're focusing is what we see in front. So when I'm drawing my moon phase, I'm going to draw what I see. A little bit of white on the left and a lot of dark on the right. All right. And so now when I turn my paper, right? When I turn my paper, let me just turn it back to regular. Remember what we said, a little bit of dark on the left, sorry, a little bit of white on the left, and a lot of dark on the right. And which one shows that is choice 2. If you want to see more practice problems of me doing these type of things, you can visit my moon phases video on my channel. Moon phases video on my channel for more practice. All right, number 9. Number 9 says the diagram below shows the moon as it revolves around Earth. The numbered location represents different positions of the moon in its orbit. Let's take a look what the question says. It says, which moon phase would be seen by an observer in New York State when the moon is at position 2? All right, so we're just going to find where position 2 is. Position 2 is right over here. So once again, there's 2 ways that you can approach this. I'm just going to approach this. Let me just approach this a little bit differently this time. All right. What I'm going to do is I'm going to just complete the orbit. All right. You see how I drew my line kind of like completing the circle orbit, the cutoff. Now remember, we're going to do the cone shape method, right? So starting from the center, draw a straight line to the edge of the circle and where the orbit is. And then it gives me an idea of what I see only in this area here. So let's take a look at what I see. Well, I see, I'm sorry. I see a little bit of white on the right. So I'm going to write a little white. It's a little white on right. And I see a lot of dark on the left. So I'm going to write this lot of dark on left. And so when I draw what I see, right, a lot of dark on the left, a little bit of white on the right. So when I do that, a lot of dark on the left and a little bit of white on the right. And I'm just going to shade this in. I know my drawing may not be perfect, but we're going to make it. All right. There we go. Get yourself some color. Here we go. Bada bing, bada boom. All right. So now when I'm taking a look, and I'm looking to see which moon phase matches it, I see right here, choice 2. Right? A little bit of white on the right, a lot of dark on the left. And so therefore my answer is choice 2. All right, let's keep going. All right, number 10, it says, base the answers to the following question on the diagram below, which shows positions of the moon in its orbit and phases of the moon as viewed from New York State. And they give us a diagram of the different moon phases. Which statement, it says right here, which statement best explains why the same side of the moon is viewed from Earth as the moon goes through its phases? So we take a look at our notes, right? And I believe that we spoke about this. Let's take a stroll down memory lane. All right, all right. We're just gonna keep on going. It's okay. We're gonna be patient, right? Becoming a better version of ourselves. There we go. And we just gonna keep strolling. There we go. So we said in our notes, from Earth, why do we always see the same side of the moon? The moon rotates and revolves at it around the Earth at the exact same rate. So what does that mean? Let's go back to our question. All right, what does that mean? That means that the rate of revolution for the moon, for the moon is 27.3 days. That means that it takes 27.3 days for the moon to go around the Earth. It also takes the rate of rotation. The rate of rotation for the moon is also 27.3 days. So the time it takes for the moon to basically do a complete spin, one complete spin also takes 27.3 days. So because of the fact that the rate of revolution is equal to the rate of rotation, that's why we see the same side of the moon. And that means our answer is going to be choice 4. The moon's period of rotation equals the moon's period of revolution. All right, number 11 and 12. So it says, basic answers to questions 11 and 12 on the diagram below, which has lettered arrows showing the motions of Earth and the moon. Okay? So it says, which letter arrow represents the motion that causes the moon to show phases when viewed from Earth, right? What is the reason why we have phases, okay? Well, the reasons why we have phases is because of the moon's revolution. The moon's revolution. So the reason why we're able to see a new moon, right? And a full moon and a waxing gibbous moon, right? The reason why we're able to see, or a first quarter moon, the reason why we're able to see all of these different moon phases is because of the fact the moon is going around the Earth, right? And what movement is that? It is movement D, the moon around the Earth. Now, yeah, your answer is definitely going to be choice D, right? Your answer is definitely going to be choice D. So I'll just circle that as your answer. I do want to take the time to very quickly, just to put some numbers around these movements, right? So the Earth's rotation around the axis, what is the rate for that? Do we remember? Earth's rotation around its axis is 15 degrees per hour. Okay? Earth's revolution around the sun is what? What is it, everybody? 1 degree per day. The moon's rotation on its axis, we know that that takes 27.3 days. And the moon's revolution around Earth, 27.3 days. All right. I should also add for the Earth's rotation on this axis to make a complete full turn, to make a complete full rotation, it takes 24 hours. And to make a complete full revolution is going to be 365 days. So these are some of the things that you definitely have to remember, especially, right, the 15 degrees per hour for the Earth's rotation, 1 degree per day for the Earth's revolution. The other one that can be found on page 15 of the reference tables. All right, number 12, it says, which two motions are completed in about the same amount of time? We literally just went over this, but let's just go through it. The Earth's rotation, one rotation takes about what, everybody? 24 hours for the Earth's rotation. The Earth's revolution takes how long for one revolution? 365 days. How long does it take for the moon's rotation on its axis to complete one? How long is that going to be? 27.3 days. And then the moon's revolution around Earth, that is also 27.3 days. Oops, sorry. And so the correct answer, right, because they want to know which two motions are completed about the same amount of time, is going to be choice C and D. The moon's rotation and the moon's revolution. If you ever forget about where to find this information, and remember, you can pause the video at any time. All right, I'm just going to clear this. You can go on the reference tables, and it'll literally tell you right here. Here we go. Focusing on the Earth's moon. Period of revolution, 27.3 days. Period of rotation at the equator, 27.3 days. So this is also on your reference tables. All right, number 13, it says, let me zoom this up more. It says, base your answers to question 13 and 14 on the diagram below, which represents the moon orbiting Earth as viewed from space in the North Pole. The moon is shown at 8 different positions in its orbit. It says, as the moon changes from location position 2 to position 6, the visible portion of the moon as observed from Earth goes as follows. So that means we're pretty much trying to find out what happens to the visible portion of the moon as it goes from position 2 all the way to position 6, right? Is a lit portion, is it getting brighter? Is it getting darker? Is it increasing or then decreasing? Is it just decreasing or increasing? That's what we're trying to find out. When it goes from position 2 all the way through 3, 4, 5, and then 6. So that means we are going to draw each of these moon phases. So get your pens ready to do this work. All right, so let's go to do this work. So let's start off with position 2, right? So same thing. I'm going to draw a straight line to the edge of the circle in the orbit. Straight line, edges circle the orbit, and cone it out. Automatically, what I see here, I see a little bit of white on the right and a lot of dark on the left. So therefore, I'm going to draw my moon phase. A little bit of white on the right a lot of dark on the left. All right. Actually, this almost looks kind of halfway. Let me fix it better. All right, so for position 2, a little bit of dark on the left. And sorry, a little bit of light on the right and a lot of dark on the left. Okay. Position 3, same thing. Draw a straight line at the edge. Straight line at the edge. Cut off. What do I see here? I see halfway. I see halfway light, halfway dark. I know my drawing ain't the best, but we gonna make it. All right, now position 4. The edge here for position 4. Draw a straight line. And when I draw my straight line, even though it may be a little bit crooked, right? I see right here, I see a little bit of dark on the left and a lot of white on the right. So a little bit of dark on the left and a lot of white on the right. So this is position 4. I'm going to do the same technique here. Draw a straight line towards the edge of the circle in a straight line. Here, all I see is white, right? That's my full moon. So position 5 is a full moon. Now for position 6, this is 2, this is 3. Now for position 6, same thing, right? Draw a line straight and then cut off. But remember, before I can evaluate, I do have to turn my paper because position 6 is in the bottom. So let me turn my paper here. All right. And so one things we have to remember, like we said, for position 6, I see a lot of white on the left and a little bit of dark on the right. So I see a lot of white on the left, a little bit of dark on the right. All right, so remember that it has to look like this. I'm gonna redraw it again once I turn my paper back to normal. All right, so I'm gonna turn my paper back to normal so I can redraw it. Remember, a lot of white on the left, a little bit of dark on the right. So when I turn my paper, and here we go. And remember what we just said, right? For position 6, and I'm just gonna redraw it here. For position 6, like we said, we see a lot of white on the left and a little bit of dark on the right. Okay. So now I'm going to check to observe to see what exactly is happening to my visible portion, right? What exactly is happening to only the lit part? What's happening to the lit part as it goes from position 2 to 6? So just from position 2 to 3, is the lit part's getting bigger, right? Position 2 to 3 is getting bigger. 3 to 4, the lit part's getting bigger. 4 to 5 is getting bigger. So from 2 to 5, we see the lit part is increasing. It is increasing. All right. Then when I go from 5 to 6, it went from full white to now mostly white, which means that the white is starting to decrease. So I'm looking for an answer that tells me that from 2 to 5, it increases, and then from 5 to 6, it decreases. And the choice that shows me that, going from increase to decrease, is choice 4. All right, number 14. Number 14 says the approximate time required for the moon to move from position 3 to position 7 is what? All right, so let's take a stroll down memory lane. All right, and so we want to know what happens, how long does it take to go from position 3 to travel to position 7? All right, here's one of the first things that I do know. One of the first things I do know, to go from position 3 all the way back to position 3 is going to be how long, everybody? 29.5 days. You can even say a little over 4 weeks. You can say a little over 4 weeks, right? So almost pretty much a month. So if I know that it takes 29.5 days, a little over 4 weeks to complete the entire cycle, what about if I just want to complete just from moon phase 3 to moon phase 7? So that means I'm completing half the cycle. So if the full cycle took 29.5 days, or a little over 4 weeks, right? So then that means that half of the cycle is going to take half that amount of time. So it's going to take about 2 weeks, right? Or somewhere between 14 to 15 days to complete half of that cycle, right? And then we would follow that same pattern if we wanted a quarter of the cycle, which would be 7 days. But in this case, they just want to know from 3 to 7. That is half of the cycle. So our answer is going to be anywhere, you could say, about 2 weeks or 14 to 15 days. And let's see what is the best answer that's given. I'm just going to clear this out. And like we said, 2 weeks. So my correct answer is definitely going to be about 2 weeks. That's the best answer. Number 15, it says basic answers to question 15 through 17 on the diagram below, which shows the moon at positions A through H in its orbit around Earth. So it says 15, at which moon position could a lunar eclipse occur? All right, well, let's go back to our notes. All right, let's go back to our notes. I know you're just going to take another stroll down memory lane. All right, lunar eclipse, boom. All right, so lunar eclipse is when the Earth is in between. The Earth is in between the moon and the sun. So I have to pick a moon position where the Earth is in between the moon and the sun. All right. And we also know that this also occurs during a full moon. Okay, I just want to show you an example of a total lunar eclipse, right? This is an example of a total lunar eclipse. And as you can see, it is a full moon, right? A lot of people refer this to as a blood moon. All right, so when I'm going back to my paper, at which moon position could a lunar eclipse occur? We just said it. It has to be where the Earth is in between the moon and the sun. So if my sun is here, because the sun rays is on the right, my Earth is here, my moon has to be on this side in order to get a lunar eclipse. And so the correct answer is choice E, because a lunar eclipse is when the Earth is between the sun and the moon. and the earth is between the sun and the moon when the moon is located right here. So the moon's position, letter E, is the correct answer. All right, number 16. It says, which letters represent two positions of the moon when the least difference between the levels of high and low ocean tides occur, right? So that means we're either talking about a spring tide or a neap tide, all right? Where there is the least difference, where there's the least difference. If we go to our notes, the tide that has the least difference is a neap tide. Why is it a neap tide? Because it says a neap tide is a situation when tides are calmer than normal. That means high tides are not that high and low tides are not that low. So in a neap tide, right, if I was to give an example, all right, your high tide may reach this height, right? That's your high tide. And your low tide may reach this height. Not a lot of difference in between, right? That's for a neap tide. If we were talking about a spring tide, for example, your high tides are going to be very high, your low tides are going to be very low. As you can see, there's a big difference of a spring tide in range compared to a neap tide. Neap tide is what we're looking for. That is what we're looking for. Neap tides has the least difference between the levels of high and low ocean tides. So now that we know we're looking for a neap tide, when does a neap tide occur? So when I look at my notes, neap tides occur, here we go. Neap tides occur during a first quarter and third quarter moon, right? Basically when the moon pretty much is in a perpendicular position, right? When we're comparing with the earth, the sun, and the moon, right? So first quarter and third quarter position, right? So instead of being it directly horizontal like a spring tide, neap tides are perpendicular. So therefore, when I go back to here, my neap tides, just like we just saw in our notes, my neap tides are going to occur where the moon's position is being perpendicular, right, compared to where the earth is. And so C and G is going to be your correct answer for 16. The two positions is C and G. Number 7, it says, how many days does it take for the moon to complete one cycle of phases as viewed from Earth? So how many days does it take to complete one cycle of phases? This is just something that you need to know. Complete one cycle takes about 29.5 days. All right, I've seen in some regions answers, they have accepted responses between 29 to 30 days, right? So if you said anywhere from 29 to 30 days, I've seen them accept that, but your best answer is going to be 29.5 days, right? Because we just want one answer. All right, number 18, it says on the diagram below, draw an X so the center of the X indicates the position of the Earth during a lunar eclipse. Well, where to draw a diagram below, draw an X so the center of the X indicates the position of Earth. Draw an X so the center of the X indicates the position of Earth during a lunar eclipse. Well, remember, in a lunar eclipse, right, we're talking about SEM. S-E-M, SEM, right? Where the sun and the moon and the earth is between them both. So in a lunar eclipse, the earth has to be between the sun and the moon. If we were talking about a solar eclipse, which I'm gonna write on the other side here, we're talking about SME, where the difference would be that the moon would be between the earth and the sun, right? But because we are not talking about a solar eclipse, we're only talking about a lunar eclipse, I have to draw, if the X represents the earth, that means that the earth has to be between the sun and the moon, right here. And that's all the questions. All right. So have a wonderful, blessed day, and I will see you next time. Take care.